everyone. In this video, I'm going to walk you through one of our questions, but I'm also going to talk to you specifically about the p-value and how the p-value relates to numbers and how we can use it. It's a pretty powerful thing to understand, and once you've seen this video and understand it, you'll start to recognize p-values all over in different kind of articles you read. But it's a very powerful tool. So in this, for this question, we have the waiting time for customers at MacBurger. This is one of the questions that's on your review. It's one on the first page, so you didn't have to do the full problem. But here we have the waiting time for customers at MacBurger restaurants follows a normal distribution with a mean of 3. So that is our population mean. So I'm going to type that here. So that's our population mean is 3. And our standard deviation of that population is 1. And because we know population standard deviation, we will therefore be using the Z distribution. At the Warren Road MacBurger, the Quality Assurance Department sampled 50, so we have a sample size of 50, so that's N, customers, and found that the mean waiting time was 2.75 minutes. So we've got our sample mean of 2.75 minutes. At the 0.05 significance level, so we've got an alpha of 0.05, can we conclude that the mean waiting time is less than 3 minutes? Okay, so when we did this first page together, if you were in class, I tell you always make sure that you are underlining what the question is. And the question is, can we conclude that the mean waiting time is less than 3 minutes? And what we're focused on specifically in this question is the mean, so I'd recommend circling that word. So if we're writing our null and alternate hypothesis statements, I'm sorry about my handwriting on the computer like this, but our variable is the mean and we are comparing it to a number. We don't have two samples, we're comparing it to a value we believe to be true. So the question was, is the mean, so here we have mu, and is it less than 3? And then everything else falls to the null, so we have that the mean is greater than or equal to 3. So here we have included all possibilities. No matter what the number is, it either falls in the null or it falls in the alternate. Okay, so now that we have our hypothesis statements, and we also know what the level of significance is, that's alpha right here at 0.05, we've also determined that we're using the Z distribution. So I'm going to go ahead and draw my normal curve here. And this is a one-tailed test because we have inequalities. So right here, because we have this inequality, it's a one-tailed test. Now we have a less than symbol, which means we're asking, is it less than 3? Remember that the population mean sits here in the middle, so we're asking, is it on the left side of the curve? Is it less than 3? So we know that we're in this tail over here. Okay? And we know that from here to here, there's a probability of 5%, because that's what alpha tells us. So what we need to know now is, what is the z-score that sits right here? That's what we have to figure out. That will give us our critical value. We can do this by going up to our f of x button, and I'm going to search normal distribution. And from doing this several times, I know that the norm.s inv is what I need. That inv end of that function is really important. We're going to use that a lot. If it says inv, what you're going to do is put in this case, a probability, and it will give you a z-score. Or if you're doing the t, it will give you a t-score, and so on. So norm.s.inv is the function I'm going to use. The probability I'm going to use is 0.05, because that's what my alpha is. So I get a negative 1.64 rounded. So I have negative 1.64. Okay, negative 1.64. Just remember that in Excel, it starts on the left side of the curve and moves to the right. So if I was in the right tail, I would put in 0.95 because I have 5% left at the top. So just be aware of that. So our decision rule is, if we get a z value in our calculation that's less than negative 1.64, then we would reject the null. So let's go ahead and do our equation. Now the equation is, write this here, z equals the sample mean minus the population mean. Always remember, sample mean comes before population mean. Otherwise, you'll end up on the wrong side of the curve. Okay, so sample mean minus population mean over standard deviation over the square root of n. That's our formula. Okay, so to solve for z, we get the sample mean minus the population mean. That's our numerator. We're taking 2.75 minus 3. That's going to give us a negative number. We know we're doing that correct, right? We want to be on the negative side of the curve. So then we divide by standard deviation divided by square root of n. Please pay attention to where all of your parentheses are. Parentheses are very important in Excel. Order of operations, that's what it follows. Okay, so we have sample mean minus population mean over, now our denominator, standard deviation over square root of n. Whenever you have a function like SQRT, you always follow that with parentheses, no matter what. Okay, so we get a z-score of negative 1.76. Let me see, this is the first time I've actually used this computer drawing with a color here. So now I'm going to go ahead and change my color. So we end up with negative 1.77 really if we round. And negative 1.77 really falls like right here. Right? So that is our test statistic. Now, because negative 1.77 is more in the tail, less than, negative 1.64, we will then reject the null. If you're in the shaded region with your test statistic, we reject the null. Therefore, we can say that the mean is less, the mean waiting time is less than 3 minutes. Now remember, that's the important part, that you can answer the question. The important part isn't that you reject the null. The important part is that you answer the question. The mean waiting time is, in fact, less than 3 minutes for the Warren Road Macburger location. Okay, so that's all well and good. That's how we do a full hypothesis problem, a hypothesis test. So now what I want to talk to you about is the p-value. And the p-value is, what is the probability of getting a number, in this case because we're on the negative side, of less than that. So we got a mean of 2.75. What is the probability of taking a sample of size 50 and getting a number that's actually that's smaller than 2.75? So what we're actually asking for is this area right here. Okay, this is our p-value. Let me go back here real quick. So the 0.05 is alpha. That's the probability of going from negative 1.64 or less. The p-value is going to tell us what is the probability of going from negative 1.77 or less. Once again, if you're on the top of the curve, if you're on the right-hand side, it's greater than, so just bear with me. All right, so the p-value is what this is right here. Okay, that's what we're going to try and find. Now we can do that by using an Excel function. So let's go back here. Let's see, I'm going to do P. And I'm going to type in normal distribution again and find the right one. So there's a lot of them out there. I think it's this norm.sidst. Now how sometimes I know this is one you can read what's down here, and if the definition's confusing, pay attention to what you have to put in order to get a value. So I have to put in a z-score and cumulative. Well, that seems about right because I want to put in negative 1.77 and I want to then get a probability. So norm.s.dist is going to give me my p-value. So I'm going to hit OK. My z-value was negative 1.77. And for cumulative, just always put true. Don't put false. Oops, if you can spell it correctly. All right. So we end up with a p-value of 0.03. Let me go here and erase this. Okay. So we have a p-value of 0.03, which means there's a 3% possibility, almost 4 if we round, almost 4% likelihood that you could get a mean of less than 2.75. So now in this case, 0.03 is less than 0.05. So we're going to compare the p-value and alpha. Now, in the past, we have compared, I'm changing color here, we have compared our critical value right here to our test statistic. And that's one way to make a decision to reject the null. Is the test statistic less than the critical value? You can do the same thing with the p-value and alpha. So if your p-value, if p is less than alpha, then you reject the null. Okay? That's another way to make that determination. The cool thing about the p-value is that it shows you the strength of the decision you just made. Okay? So for instance, this is 0.03, which is a fine number, and it is less than 0.05, so we do reject the null. But what if instead of choosing an alpha of 0.05, we had used an alpha of 0.01? Well, in that case, 0.01, our alpha, is bigger than p, and in that case, we would fail to reject the null. So p-value of 0.03 is okay, but it's not really strong. If we had a p-value of 0.00001, we would be extremely confident in our choice to reject the null and accept the alternate. So that's the strength of the p-value. And in the future, in some of our other classes, we'll specifically just go look at the p-value. We won't have to deal with the critical value. It just kind of depends on the test. But you can look at the p-value and determine automatically, do we reject the null? And you can also then decide, am I really happy with that choice, or is it really close? And then maybe we should take another sample, at least when you're dealing with the real world. Okay, so that's in a nutshell the p-value. We will talk about it more as we move into class, into other areas. It's not going away. And hopefully this helps clarify some of the questions you may have had. One other thing before I go, this was all a one-tailed test. If we had done a two-tailed test, we would have doubled that p-value. So instead of 0.03, it would have been 0.06. Just another thing to keep track of. If you're working on your homework, something doesn't come out right, ask yourself, was it a two-tailed test? Did I need to double it? Okay, thanks for listening, and we will see you in class.